Okay, this starts our material for the next test that we will have. It's section 5.4. It's A because it's only the first three objectives of this lesson. We are talking about systems of linear equations in two variables. So to refresh your memory on what that is, a system of equations is a set of two or more equations with two or more variables. Now, the solution, excuse me, the solution of a system is the set of values for which the set of values for the variables that make all of the equations true. And the answers are always written as ordered pairs. So the types of questions that we need to concentrate on for this lesson, first off, can you determine whether or not negative 4, 3 is a solution of the system? Okay, if it is a solution, then it must be true for both equations. Okay, so that's the thing that you need to remember. You can't just try it on one and say it works. So to do this, what you want to do is write each equation, and instead of writing the variables, we're going to put parentheses. So this is a variable plus 2 times another variable is equal to 2. And then on the other equation, I have a variable minus 2 times another variable is equal to 6. So what am I supposed to plug in? Well, they're asking if this is a solution. This, of course, is your x, and this is your y. So wherever I see x, I'm going to put negative 4, which is the first one in this one, and the first one in that one. And then wherever I have a y, I'm going to put 3. So I put a 3 in for that y and a 3 in for that y. And then I'm going to simplify each of those equations. So this becomes negative 4 plus 6. Does that equal 2? And yes, when you combine negative 4 and 6, you get 2, so that works. And on this side, I have negative 4 minus 6. Does that equal 6? Well, negative 4 minus 6 equals negative 10, which does not equal 6. So yes, it's true for this one, but it's not for this one. So determine whether or not it is a solution. Then we say negative 4, 3 is not a solution to this system. Okay? Now, we have several different ways of solving them. This one they gave you the answer, asked you whether it was true, but more times than not, you're going to be given a system and you're going to have to solve it. So the first method that we're going to talk about is by graphing. So we're kind of putting together what we just learned. Okay, so remembering the ways to graph, if we start off with this first one, that's in that form of ax plus by equals c. So when I graphed that, that was the one where it was easy to use the intercepts. And I look at it because 2 goes into 6 and 3 goes into 6. So when I find my intercepts, they're going to be nice whole numbers, or integers, excuse me. Could be negative, positive or negative. So the first one was if I plug in 0 for x, and the second one is if I plug in 0 for y. So when you do that, if I put in 0 for x, I'm left with the equation 3y equals 6. Divide both sides by 3, and y equals 2. So that gives me the point 0, 2. If I put in 0 for y, this goes away, leaving me with 2x equals 6. Divide both sides by 2, and x equals 3. So I have the intercept of 3, 0. So I'm going to go plot 0, 2, and then 3, 0. And as we do this, you need to make sure, actually I should have said this at the beginning, whenever you solve by graphing, okay, you must use graph paper and a straight edge. This is the least accurate method of solving a systems, but it's even less accurate if you don't use graph paper and a straight edge. Okay, so I have those 2 points, and now I'm going to connect them with my line. This is not one of those where I'm necessarily judging your line. Your line is helping you to connect them. So let's go. I'll see how that works. If I put it like this, looks like I've got my points connected. Okay, so I'm going to. All right, those are my arrows on my lines. Okay, the next one, the next line that we have, 2x plus y equals negative 2. Not, I mean, you can do your intercepts if you want. Actually, that does work in this case, but I just want to give you another way to do it. You might be more familiar or feel more comfortable if you subtract 2x from both sides here and come down to y equals, these don't both have an x, so you cannot combine them, negative 2x minus 2. And that other way, this was our slope-intercept form. Um, so I'm just refreshing your memory on the different ways that we have to graph lines. Yes, you could have used intercepts here. And that means that we start at the point 0, negative 2, because that's my y-intercept. And then my slope is the coefficient of my x right here, so that's negative 2, which is the same as negative 2 over 1. And so when I graph that, negative 2 over 1, and actually I'm more interested in going towards this line, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, because I'm looking at, it looks like that's going to be the point where they intersect. But I am still supposed to graph it, so I'm going to connect these with a line, because that would be what the graphing part of it is. Okay. So these are my two lines. And to find the solution, which is what solving is, I'm looking for the point of intersection, which is right here. So this point, coordinates of this point, 1, 2, 3, that's negative 3 because I went to the left, and then up 4. Okay? And because it is not the most accurate method, you need to make sure to check your answers. And actually on all of these problems you can check your answers. So you can easily know whether or not you're doing it right and get 100 on your test. So when I do this, let's go into that first line. You have to check it into both as we said in the beginning. So when I write this, I'm going to write 2 times my variable plus 3 times a variable equals 6. That's the first line. And the other one was 2 times a variable plus a variable equals negative 2. And what am I using to plug in? This is my x and this is my y. So for x I'm putting in negative 3 and for y I'm putting in 4. And then I'm going to carry forward. So 2 times 3 is negative 6 plus 12. Does that equal 6? Yes, 6 equals 6, so that one's true. And over here I have negative 6 plus 4. Does that equal negative 2? Negative 6 plus 4 does equal negative 2, so negative 2 equals negative 2. And since that is the case, then I will box my final answer of negative 3, 4. Okay? Now, when you check for me, you don't necessarily have to write down all those steps. The most important thing that I'm looking for when you do this is this right here. Okay? And I'm fine with it if you want to write it down like that and then go ahead and put your check mark up here. That just shows that you've checked it. But that's a great way to know whether or not you're doing it right or wrong. Okay, that's one method, solve by graphing. The second one is to solve by substitution. So I'm going to list the steps and then I'm going to go through the steps so you can see how to do this. And I write down just the basic steps, and if you need to know more detail about it, then you can read here. The first one is that you want to solve either equation for one of the variables. You'll see as I go through it. The second one is you're going to substitute the expression found in step 1 into the other equation, and I have a way to help get that straight. Then you solve that equation for the variable that it has, and then they call it back substitute instead of just substitute, because what you're doing is you're going to substitute back into an equation that we just created. And then last but not least, you want to check to make sure. And again, check in both of your equations. Okay, so I'm going to go through each step. The first step is to solve. Well, there it is done for you. They have solved one of the equations for a variable. That means get one of the variables by itself. So I solved that variable. Excuse me, that equation has been solved for y. And so now I'm going to substitute. And I think the best way to substitute, I've found most success with my students when they circle what it equals and then they draw a line to where they're going to plug it into the other equation. So when I go to step 2, that I'm going to substitute, I'm going to write this equation 5x minus 2 times a variable equals 8. And that variable is what I'm substituting in for the y. So instead of writing y, I'm writing the expression 3x minus 7 because that's what y was equal to. So then we're going to solve. That's step 3 is to solve this equation for that variable. So we would have 5x minus 6x plus 14, because you have to distribute the negative 2, equal to 8. 5x minus 6x is negative x plus 14 equals 8. Then I subtract 14 from both sides to get my variable by itself. Negative x equals negative 6. Divide by your negative 1. And x equals 6. Okay, so that's basically step 3. We solved the equation for one of the variables, so that was the process of that. Okay, step 4 says back substitute. And back substitute means you're going to go back to this one and you're going to substitute what you just got in for that variable. So that means y, because I'm looking for y, equals 3 times whatever x equals minus 7. Well, what did I get for x? Right here. Okay, x was equal to 6. So I plug in 6, and y is equal to 18 minus 7, or y is equal to 11. Okay, and the last step that you have, 5, says check it in both of them. So I'm going to write a variable. Oops, let's go back on that. Um, a variable is equal to 3 times another variable minus 7. And my other equation says 5 times a variable, not equals, thought it would do that, 5 times a variable minus 2 times a variable equals 8. And then I'm going to go back and I'm going to look and see what they equal. Okay, this was y, so y was equal to 11. This is 3x, and x is equal to 6. This is 5x was equal to 6 minus 2y, which is equal to 11. Okay, so you can easily put that into your calculator. Okay, 11 equals 18 minus 7. That one checks. 30 minus 22 equals 8. That one checks. So the answer to my problem has to be written in an ordered pair. So my answer is 6 comma 11. And we box it so we know that that's like putting in the answer blank on your test. Okay, now a study tip here, it says you can choose which variable to isolate in which equation. You can do any of the variables, but it's easiest if you will find the variable whose coefficient is 1 or negative 1. Now this one was already done for us, but if you look at this next one, okay, you can choose, this does not have a variable of 1 or negative 1, and neither does this. These both do. But since that's positive one, that's the one I'm going to choose to solve. So I'm going to add y to both sides. And this is going to give me x equals y plus 3. Now, that's y plus 3. These don't both have a y. I cannot combine them. Okay? That is step one. I took an equation and I solved it for a variable. And now I'm going to take this is equal to x. So I'm going to take this and I'm going to plug it into the other equation for x. So when I write that, it's going to look like this. It's 3 times a variable plus 2y equals negative 1. Because I said I was going to plug in for that x. And what does that x equal? That x equals y plus 3. So then we go to solve, and you got to distribute. So that gives me 3y plus 9 plus 2y equals negative 1. Combine my like terms. 3y plus 2y is 5y plus 9. Then I'm going to subtract my 9. 5y equals negative 10. Divide by 5. And we find out that y equals negative 2. So this was the third step, this whole process basically, solving for a variable. So step 4 is when I do the back substitution. So I'm going back to that equation that I had, and this time I'm looking for x because I already have y, and it's equal to whatever y was plus 3. And we just found out right here that y was equal to negative 2. So if I put in negative 2, x equals negative 2 plus 3, which is 1. All right, and my checking, okay, we wrote 3 times a number plus 2 times a number equals negative 1. That's one checking. And the other one is a variable x, whatever x, it's not plus. Yeah, minus a variable equals 3. And what are my variables? Okay, 3 times x. I look back, my equation x is 1 plus 2 times y is negative 2. X is 1, y is negative 2. So put it in your calculator or do it. 3 plus negative 4 is negative 1. That works. 1 minus a negative 2 is 1 plus 2, and that's 3. So the answer, x equals y, and excuse me, x equals 1 and y equals negative 2 is our answer. So we put a box around it. Okay, so the last thing that I want you to write on your paper down here at the bottom, I want you to write number 37 to 47 on the back or another piece of paper. So write that down and then bring me your note sheet and I'll give you your classwork. What I'm referring to in that statement is that these problems, I gave you the graphs to do, but these problems, don't try to squeeze them in there. There's too much work that needs to be done. You can either turn your paper over and do it on the back of the paper, or you need to get another piece of paper and do all your work on another sheet of paper. As always, please let me know if you have any questions.